Hello everyone, my name is Kishan Agarwal. Today I'm going to present my AAT Tech Talk of Software Project Management, and my topic is handling non-functional requirements in information system architecture design. So let's begin with what is non-functional requirement first of all. Non-functional requirements or NFR describes the operational attributes of a system, focusing on how it performs rather than specific behavior. Example, it may be security, performance, scalability, usability, reliability. These all are non-functional requirements which are which do not help in the functioning of the software but are important. Hence are termed as non-functional requirements. So what are the objectives of this? Highlights the critical role of non-functional requirements in shaping system architecture to meet quality standards and user specific expectations. So information system architecture design is a complex task depending on both functional and non-functional requirements. Since system architecture definition is strongly related to system performance, non-functional requirements plays a significant role during enterprise information system design. To explore the effect of non-functional requirements on system design process, a model-based approach emphasizing non-functional requirements is proposed to facilitate the designer to effectively design and handle requirements during architecture design. A number of system views are offered, and each of them focusing on discrete design issues and satisfying different kinds of requirements. A consistent requirement model is defined representing how non-functional requirements are related between them and to the system components forming the overall system architecture. Next, we'll move to the importance of non-functional requirements in system architecture. So non-functional requirements ensure the system's overall quality and user satisfaction. How it impacts on our business. Direct influence on operational efficiency, user experience, and competitive advantage. Next is risk mitigation. Early identification and addressing of potential risk and bottlenecks. Categories of non-functional requirements. Performance. Performance is the measure like response time, throughput, and latency. This all makes the performance of the software. Scalability, the system's ability to handle increased loads. This defines how scalable your product or software is. Next comes security, which is more important. Protection measures like data encryption and access control and different security measures which need to be taken during the development. Usability, ease of use and accessibility for users. Reliability, system availability, fault tolerance, and recovery capabilities. Maintainability, ease of system updates, enhancements, and modifications. So non-functional requirements indirectly helps you sustain in the market, and also it will help you improve your user base. Like if your product is more scalable, it provide more security. That means how your product provides non-functional requirements, your demand of the product or the market value of the product will increase. So non-functional requirements plays an important role. Incorporating NFR, non-functional requirements in architecture design. So first of all, requirements gathering, engage stakeholders to identify and prioritize non-functional requirements And then comes your documentation, that is clearly documenting non-functional requirements alongside with functional requirements. Next comes your design principles. That means which principles like architectural patterns and principles that supports non-functional requirements. Example, microservices for scalability, layered architecture for security, and different principles to incorporate all your non-functional requirements categories. Performance considerations. Load balancing. Distribute workload across multiple servers to improve response time and throughput. Caching. Implement caching mechanism to speed up data retrieval. Asynchronous processing. That means use asynchronous operations to handle tasks concurrently. So example, content delivery networks, CDNs, for caching static content to reduce server load. This is the best example where performance consideration is done. Next comes your scalability strategies. Horizontal scaling, vertical scaling, elastic scaling, and all. So what is scaling? Add more machines to the system to handle increased load. That is horizontal scaling. Enhance the capacity of existing machines. Vertical scaling. Elastic scaling automatically adjusts resources based on demand. That is elastic scaling. The scaling provides how you handle the increased load or how you improve your machines or how you adjust the resources allocated to different process running during handling the load. Example, using cloud services like AWS, auto scaling to manage resources dynamically is the best example. Next comes security measures, authentication and authorization. Ensure only authorized users can access the system. Now, if you are using a system, computer, you'll protect it with some kind of password that particular user can only use your computer by using the password. That comes authentication and authorization. Data encryption. Protect data in transit and at rest. That means every data which you are sending to server for the request and the data which you are receiving from that end should be encrypted before it is loaded into the channel. Vulnerability and management. Regular updates and patches to safeguard against threats. Example, implementing out 2.0 for secure user authentication and access control. Usability enhancements. Intuitive interfaces, accessibility, user feedback. That means design should be user friendly and it should be intuitive interfaces. Accessibility. Ensure the system is accessible to users with disabilities. User feedback. Incorporate user feedback into design improvements. This is very important to get regular feedbacks from the user so that you may improve your product in next incremental model or your next build or next version. Example, using responsive design to ensure usability across different devices and screen sizes. Ensuring reliability, redundancy, failover mechanism, disaster recovery. I'm discussing only a few techniques, or you may call it as few ensuring the non-functional requirement techniques. There are many more. So redundancy, that means add duplicate components to enhance system availability. Failover mechanism, You should implement automatic failover to backup system in case of primary system failure. Disaster recovery, develop and test disaster recovery plans to ensure quick recovery from catastrophic events. Example, utilizing multi-region developments for redundancy and failover. For example, different companies like Google use different servers placed across different continents so that if one fails, you may receive the data from other. Maintainability and evaluation. Modular design. Design system in a modular way to facilitate updates and enhancements. Documentation. Maintain comprehensive and up-to-date documentation. This is very important so that the new team members who are currently joining your project, or if you're solving some particular problem after delivery of your product, it will be very helpful. Automated testing, use automated tests to ensure changes do not introduce new issues. Example, using containerization like Dockers to ensure environment consistency across development, testing, and production. Conclusion. Integrating non-functional requirements into system design is essential for building robust, scalable, and secure systems. Involve stakeholders early and continuously. These are the best practices which we can inculcate in our product development life cycle to improve or to integrate these non-functional requirements into the product. Regularly review and update non-functional requirements as the system evolves. Use appropriate tools and technologies to address non-functional requirements effectively. Thank you.